Ever wondered what makes your electronic devices tick? A vital piece of the puzzle is the P-N Junction Diode. Welcome to the intriguing world of these tiny yet powerful components. The P-N Junction Diode, a fundamental building block in electronics, is a two-terminal device made from specially treated semiconductor materials like silicon, germanium. But what's so special about it? Well, its magic lies in its ability to control electricity. It allows current to flow easily in one direction, much like a river flowing downstream. Yet it puts up a strong resistance when current tries to flow in the opposite direction, like a dam holding back the river. This unique characteristic is what makes it an essential part of many electronic devices we use daily, from radios to computers. So, how does this tiny component achieve such a significant feat? The answer lies in its intricate composition and functionality. Stay tuned as we delve into the fascinating composition of the P-N Junction Diode. The P-N Junction Diode begins its life as two differently doped regions of semiconductor material. Now, what exactly does that mean? Let's break it down. Doping is a process where we intentionally introduce impurities into a semiconductor. This creates more electrons or electron holes and forms what we call the N-type and P-type regions. In the P-type region, we introduce dopants with 3 valence electrons, such as boron. These dopants create holes, which you can think of as positive charge carriers. They're like vacancies waiting to be filled by an electron from a neighboring atom. On the other hand, the N-type region is doped with elements having 5 valence electrons, like phosphorus. These dopants donate an extra electron, creating a free electron that can move around. Now we have 2 distinct regions. But what happens when these 2 regions meet? Let's find out. The magic happens when the P and N-type regions come together, creating a junction. Now imagine the electrons from the N-type region start to wander off, diffusing over to the P-type region to fill the holes. And just like that, holes from the P-type region get curious and diffuse towards the N-type region. This exchange forms what we call the depletion region. This region is interesting. You see, it's not teeming with mobile charge carriers like the rest. Instead, it's almost barren. The P side of the region carries a positive charge, thanks to the immobile acceptor atoms. On the flip side, the N side holds a negative charge, a result of the immobile donor atoms. This depletion region, right at the junction, is a bit like a checkpoint. It keeps a check on the flow of electrons and holes. This junction is key to controlling the flow of current. But how? That's up next. The diode's secret to controlling current lies in a process known as biasing. This process involves applying voltage to the diode's terminals. Now, there are 2 ways this can go: forward bias and reverse bias. Forward bias happens when we apply a positive voltage to the P-type side and a negative voltage to the N-type side. This reduces the width of the depletion region and allows the majority carriers, that's electrons in the N-type and holes in the P-type, to flow easily across the junction. The result? A significant current flow. On the flip side, we have reverse bias. This occurs when we apply a positive voltage to the N-type side and a negative voltage to the P-type side. The depletion region widens, creating a stronger barrier and making it quite difficult for current to flow. Only a small leakage current exists due to minority carriers. And that, my friends, is the amazing world of the P-N Junction Diode. Remember, forward bias allows high current, reverse bias allows minimal current, and the voltage required to overcome the barrier is the forward voltage. Want to build your own mini circuit with a diode and witness its power firsthand? Or maybe you're curious about how diodes light up our world with LEDs? Let us know in the comments what sparks your curiosity, and we'll be sure to cook up another electrifying video just for you. Don't forget to like and subscribe for more adventures in electronics.